AWS or something. That's not the right computer. Off to a great start. Anyway, first PSA. Metropolis, this bullet used to say they were missing somebody, and then literally earlier today, somebody signed up for a Metropolis team. So they're going to roll. Metropolis is a competition at UMD. It's in person. It's like pretty much all day. It's like 9 to 4 or something. Happening this weekend. We've got like 20 or 25 people going there. Honestly, I wouldn't jump in on it at this close to it, because you would have to put together a team of 4, which just isn't going to happen this period of time unless you have 3 people you already know you can call. But just a PSA that Metropolis is happening this Saturday if you see anything about it. Pico CTF is happening. Pico CTF is online. I know you guys were just talking about it a minute ago. It has a wide range of difficulty. Like there's some easier problems and some like insanely difficult problems. It claims to be targeted at middle and high schoolers, but university people do it all the time. It's online. There's a channel for it. So in our Slack, so I encourage you to take a look at it if you want CTF experience, especially if you're going to Metropolis and you haven't done like anything, because you don't want to get blindsided at an in-person multi-hour event, because that's just a bad time. So take a look at the channel, take a look at, if you want to register your own team, because like 80% of them are probably solved in that channel at this point anyway, do whatever you want. I just encourage you to check out Pico CTF. So it's run by Carnegie Mellon? Yeah. AWS Primer, there's like all kinds of numbers out about this. 30 is very conservative, I would say, but they're pretty dominant as far as cloud goes. There's competitors include Google Cloud Platform, Azure, and then depending on how you look at it, there's like more fringe like Rackspace or DigitalOcean, but they're kind of different. It's relatively easily programmable cloud infrastructure. They have like 1 million services to do different things, whether it's storing files, spinning up servers, running arbitrary Python code without worrying about the servers, called Lambda. Just a ton of different services, databases, et cetera, et cetera. They tend to have a reputation for getting expensive. Whether or not you consider them expensive or people consider using it wrong expensive, there's just an air of that around them at times. But pretty, like, extremely reliable. AWS does their best to try to not make you shoot yourself in the head when you use AWS, but that doesn't always happen, so there's still people who manage to set up their AWS stuff wrong, which is what we're going to talk about a little bit. Reason being, and Nikki talked about this before we started a little bit, but there are fringe use cases for an otherwise insecure setup. So if you have a bucket of data that's world readable, in some cases that's considered a really, really bad, stupid idea. And then in some cases, maybe you're just serving pictures for your website. So they don't step in always, because there are valid use cases for otherwise insecure setups. There are 2, if you want to get hands-on as a student, there's 2 options you can look at. Regular, when I say regular, I mean both of these. I would talk about AWS Educate. Regular as in just a regular account. Generally have to link it to a credit card. Most people, I would say, get out fine, but every now and then somebody will be like I spun up 1,000 Bitcoin miners and I got an invoice for $1,000. What is this? Like, people sometimes just screw up and they link it to their credit card. You can apply multiple discount codes if you're worried about money, but you have to actually have those discount codes, whether they're from events or from or MLH. Hackathons love giving them out. There's also something called AWS Educate. You get $100 in AWS credit if you sign up for it. The alternative is a starter account. Starter account gives you certain services. I read the docs and it seemed like all indications were they don't really let you do anything with IAM, which is pretty key from a security perspective. So that's a big gap if you're doing starter. You don't need a credit card. It's technically externally managed. There's like a cloud training company called like Quick Labs or something like that. They technically handle the starter accounts, but I don't think that would really matter to you. And your account just straight up blows up when your credit expires. So when you set it up, you get like $75 in credit, I think every 12 months. If you use up that 75, just everything blows up. So back up if you're using that option. Just be generally cautious if you're using that option and keep an eye on your billing. There's also no adding after the fact, according to their docs. Like you supposedly can't take a starter and then just be like, okay, I'm ready to throw a credit card on it. You're a starter account or you're not a starter account. So I believe, don't quote me on this part, but I believe you can't also just stack credits onto it. I think it's like your $75 and once you're done, you're done. You can renew annually, but so those are two options if you're a student and you're looking at getting into AWS. Normally, when we do this talk, we put out it takes 48 hours maximum for this kind of stuff to process. Usually we put out the form ahead of time, but I wanted people to be actually informed about starter versus regular before they put that in, because previously we just defaulted people to regular, and I don't want anybody who just has no idea what they're doing and is flying by the seat of their pants getting billed $100 before the talk even starts. So, fun fact as far as club goes, we went to Herndon, the AWS security office last year, and they had a coding challenge. They called it 3 different things. It was like a hackathon or a coding challenge or a CTF or whatever. Basically, it was 6 challenges of varying, mostly programming, less security. One was SQL injection. One was required really, really intimate knowledge of Git. One was basically passing Ruby test cases, et cetera, et cetera. We did that, and it ended in a 5-way tie for first. So they just raffled. The winner team was supposed to get echoes. It was really there were 8 teams, 3 got first or something. The winning team got echoes, so they just raffled them. I got an echo, and Matt Burke, who I think since graduated, got an echo. He was doing a senior design project last year, so I would assume he graduated. Wait. Okay, here we go. Common services, some related to security. CloudWatch. A lot of people mix up CloudWatch and CloudTrail. CloudTrails are actually good, forensic logging of stuff happening in your AWS account. CloudWatch is just keeping an eye on things. Tends to be per metric. For instance, if you have a server that's really, really crushing on CPU, you can point CloudWatch at it and say, just arbitrarily hook it up to other AWS services. So you can say email me if this instance is at pegging at 95% CPU. Just it's more for keeping an eye on things from an IT perspective. CloudTrail is where 99% of the actually good logging is. Everything in AWS is basically an API action. Yeah, so ignore how half of this is off, but basically everything is an API call in AWS. So when you're visiting a bucket, or when you're trying to list your buckets, it's making an API call to AWS list buckets, this signed by this user with this key or whatever. Everything's an API call. You can ban things based on the API call level. I can say don't let Zane list buckets, and whether he's programming using their tools or he actually logged into the console and is trying to visit to list buckets, it'll deny him. So everything's pretty much API level. CloudTrail will log those calls. I can give an example of this later. I'm hoping to log into my company account without something brutal happening. EC2 is probably the most common one. It's basically virtual machines. All the VMs are basically referred to as instances. If you're familiar with VPSs, 99% of EC2 is just VPSs. I think technically you can do dedicated in EC2, but I haven't heard of anybody doing it. They could. I'm sure there are people who do it, but generally it's just virtual private servers. S3, it's file storage. Files are called objects. I believe the file name is called a key. I don't the distinction's kind of weird. People usually use the terms interchangeably, but it's like files are objects or keys, basically. RDS basically piggybacks on EC2, but it's database servers. They're actually managed, so you can just say, replicate it, back up to this. This is my maintenance window. Give me a MySQL server, and it'll do it. I know people, I overheard at least one IT design group using RDS for their capstone project, which actually surprised me because in theory it would take you like a couple hours to set up, so that's going to be the most anticlimactic capstone project of all time. But of note, I come from a forensic background, so I care about this a lot. RDS, you don't just like SSH or remote into RDS. You can MySQL or whatever database it is into RDS, but you don't get like shell onto the server with RDS. The reason that matters is if RDS is compromised, you have to query AWS for the logs and stuff. You can't just remote into an RDS server and just start screwing around on the actual box. The reason I say it hooks into EC2 is it's basically just spinning up an EC2 instance, doing all the config for you, but technically giving you less access, which is kind of what people tend to refer to when they say managed. So, config, I have like a big beef with like config being called config because it's like the most ambiguous name you possibly could have given a service. But the idea with config is you can set rules and have those rules fire based on things happening in your environment. So like we have a couple common sense rules at our company. If somebody creates a bucket for S3 data that's read only, or that's public read, anybody can read from it, there's no valid business case for us to have that. So we have a config rule that emails me if that happens. You could also technically set that config rule to just delete the bucket outright. It's very arbitrary on what action you want to take. You can say, another one we have, for instance, you can do it with whatever service. So another one we have, for instance, is if somebody spins up a really, 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 really big EC2 instance, email us, like over $1,000, then like email us saying, because we usually do it on an ad hoc, like doing it for this little client, like just need a pivot in EC2. We don't use EC2 that much. So we have a rule saying if you spin up an enormous EC2 instance, at least let us know. And it'll email us if it spins up an enormous EC2 instance. Again, email's kind of arbitrary. You could have it shut down the EC2 instance. You're just linking AWS services to each other, really. Inspector, I haven't played with Inspector personally. Nikki, you said Inspector's pretty popular there, right?
Yeah.
Or?
Yeah, I entered on the team that originally built Inspector before it split off. Yeah, it checks for making sure that you're keeping your patching up to date automatically, and try to see like, very, very small amounts to just make sure that like you have the stuff that's set up when it's good or whatever, and it's super cheap, so it's like easy to just
Nice.
make sure that you're not using anything super terrible.
Gotcha. Yeah, config's like $1 per rule, and that's pretty much just how building a config works.
I think Inspector is like less than a cent per run, like kind of like a cent.
Yeah, nice. Macy is relatively new. Macy can look at your S3 data, I believe, and tell you, and basically classify data based on sensitivity of it, I guess. We don't use it because all of our data in S3 is client-side encrypted, so it wouldn't have any means of actually classifying it. But like our keys and everything are on premises, so they would have no way of classifying it. But it's for data classification of otherwise, like whether that's AWS side encrypted or unencrypted data, to figure out whether or not basically you have sensitive stuff in the wrong place. There are a number of either security or security adjacent AWS services. They list them all here. You can also just Google AWS security services and they'll show up. For instance, one we don't talk about is there's a web application firewall service. It's like a million other security services. Again, AWS has like a bazillion services. And if you've ever used AWS before, or you do end up using AWS, when you go and log in and you like services and stuff and there's only 30 and you're like, they lied to me. It's not a one-for-one. So like EC2 is on there, but EC2 uses something called KMS for keys and all that. KMS tends to be referred to as its own service because you can also use KMS for other stuff. So it's not, it's not one for one just looking at the board and being like, there's only 30, everybody lied to me. There's like stuff in the background. Flaws.cloud. It's basically running CTF for like choose your own adventure, CTF for AWS. You can get through like the first 3 to 5 levels without an account, but after a while you do need, like it is authenticated actions. They give you a ton of hints. Like you could just press hint 1, hint 2, hint 3, hint 4 and make your way to the solution if you really wanted to. It's not necessarily scored, but it's pretty perfect from a CTF club looking at AWS perspective as far as learning AWS stuff. It's very particularly security. It starts with a heavy focus on S3 just because that's presumably easy to, A, a lot of people misconfigure S3, and B, it's easy to just run a CTF around S3 stuff because you don't have to give anybody any particular access. Moves towards EC2, and I actually don't think I made it past either of those, so for all I know, it just starts going into obscure services. S3, like I said, file names, keys, files, objects. The top level folder is a really bad way to describe it, but you basically have buckets of data, and they're distinct. I can't have the bucket Mason CC and Zane have the bucket Mason CC, even if we're separate accounts. Like they're completely distinct names. They're globally recognized throughout AWS. This is your bucket Mason CC. For instance, our company, Crypsis Group, all of our buckets automatically get tagged -Crypsis Group, just so nobody like creates a bucket that's colliding with another company in an application. It's used for a lot, secure file storage to content delivery. If you're doing content delivery, there's also a service called CloudFront that people tend to hook into that kind of stuff. D. Haynes, I think you run CloudFront for Circuit. That's a big issue as far from a security perspective when you consider the same people storing social security numbers in S3 are the same people serving the JPEGs for their website through S3. You can see how people just make really stupid configuration errors. So buckets commonly get set to the wrong stuff. Nowadays, AWS got really good about this. AWS will show you like 500 alarms on your console if you set something to public. Like it'll set the tab orange and say public. It'll show at the top of your S3 saying something's public here, and it'll show in like the columns of where all your buckets are listed, this is public. So they're trying really hard to not make you shoot yourself in the head, but you can still shoot yourself in the head, especially if you're not using the console. What? Yeah.
We get like regular emails about what our public buckets are.
Yeah, and I would also say they also, if you, they're also able to tell if it's public, even if you don't hit like this like green star or whatever. Mm-hmm. Like they've like tried to make it so that you can't even do like you can't even set it to like that they'll be warned if you set it to public, even if it's not an obvious thing that's set to public. So.
We've had that happen with like we don't necessarily go into the console and click read public if we ever do make a public bucket. We tend to write, if you're ever familiar with JSON, a lot of policies in AWS are written in JSON. If we miswrite a policy and it makes the bucket public, it'll flag that and be like, you've somehow managed to make this public anyway. So they're pretty good about that. Bucket stream, so ever so gracefully sliding into the exploitation side. Bucket stream, it's on GitHub. It says it does stuff. Okay, so it looks at certificate transparency logs, which are recent. Certificate transparency logs are basically from people requesting HTTPS green lock certificates, and now they made it so you have to, if you're issuing those certificates, you have to basically tell a couple servers what you're issuing and who you're issuing to, just to make everything more transparent and obvious about what's happening behind the scenes with that. It'll look at that, and it will look at permutations. I think it uses like a dictionary or something in the back end. It looks like permutations and just kind of brute forces through and checks buckets as they're coming up. And it'll tell you not only, it'll tell you pretty much what's on screen. It'll find random buckets that are like either read unauthenticated, full control unauthenticated, or I believe it'll even tell you this bucket, you can take full control of it, but you have to, if you give it keys, but you have to like actually log in. Anybody logged in can have full control of this bucket. You can set it so it'll answer that too. From a CTF perspective, this is of absolutely no value to you. From a pen test or whatever perspective, I'm not sure if you'd be able to tune it to a degree that it would be useful. But from a just malicious standpoint, and if you're ever wondering how people manage to just start hammering random company buckets, this is the kind of thing where people would just watch and find a bucket and just be like, I know, I'll push. I think it shows here. Yeah. Really, really desperate people who don't have time to do real bug bounties, apparently, will push text files saying, hey, I found this bucket, and I pushed a file to it. You should really lock it up before somebody meaner pushes a file to it or downloads files they're not supposed to. Though it's really commonplace with public buckets now that just like disclosures show up in their buckets. So I found that kind of interesting. Everybody gets when you make a bucket, everybody gets like the domain name, like say our bucket is Crypsis Group. It's crypsisgroup.s3.amazonaws.com, and I think there's a couple other DNS names you can use to reach it. But if you just visited it in your browser, you would always get back XML, because that's how their APIs tend to translate. But you would either get some access denied message or a listing, as you can see kind of underlapped over here. You can see saying key, this is the file, the last modified date, E tag, I think it's just supposed to be a distinct tag. I think in theory people assume it's an MD5, but it's not, because AWS warns people to not use it as an MD5 hash. Storage class, standard. If people are archiving stuff, they'll usually set it to something else like IA or Glacier, or just like something cheaper but more expensive to retrieve. But most stuff is just set to standard, and just like the size of it and stuff. So then if you see that, you see users-19-whatever.jpg. You could literally go into your browser, go to the domain name -users-19-whatever.jpg, and then probably pull it down depending on their access control. If they set their whole bucket listing to public, there's a chance they set the actual retrievable files to public. And if they did, then you would literally be able to visit it in your browser and it'd download. In some cases, you need to be authenticated, but they don't care who you're authenticated as. So then you log in and do it, but then they have strict attribution. This guy, you risk them logging and saying, this guy downloaded our social security numbers, go get him. Nailed it. EC2, like I said, servers are basically instances. Security groups, I'm a big fan of layman speak metaphors, so some of these are imprecise. But security groups are basically firewall rules. Let this IP address in at 22. Let this, let whoever wants in on 443 if you're running a website, that kind of stuff. Security groups, people screw up a ton. People will create not only from a security perspective, but just from trying to use AWS, they screw up security groups a lot. They'll try to set up a website and they'll have everything set up in the instance perfectly. And they'll be like, why can't I visit my website? It's because you didn't go to the security group and turn on 80 and turn on, if you're doing HTTPS 443, you need to let in that traffic through the security group. By default, it only lets in the management ports. So if it's a Linux box, 22 for SSH. If it's a Windows box, 3389, I think, for remote desktop. So by default, security groups are relatively anal. You can set up security groups. For instance, we have one that's like web from our internal IP space, and just apply that to a ton of different instances. You're not applying it per instance. You're just creating these sets of rules and applying them. And those sets of rules are what the actual security groups are. A VPC, really crude description, but it's a step above a subnet. It's like a private network segment. Volumes are, spoiler alert, volumes. They're disks. They're pretty symmetrical to what the term volume is on an actual machine. but they're handled differently in AWS because it's cloud. Similar to a lot of VPS providers, you'll find DigitalOcean kind of mimics certain stuff. Like in DigitalOcean, you have droplets. Those droplets are pretty much instances. I mean, heck, DigitalOcean has a way to store files, and it's S3 compatible. You could literally point S3 tools at DigitalOcean's file storage system, and it'd work. So a lot of these companies run similar, but AWS kind of set the specs and all that. Instance types are huge. They determine the specifications of the server and the cost. So a lot of people mess around and joke around with like tier 2 micro, tier 2 small. Those are like the smallest instances. I think there's a nano. It's like the smallest instance types. You get like less than a gig or a gig or something like that of RAM. It's little stuff, but you can pick like M4.4x large, and it's like, they have charts for all of this. It's like a ton of RAM, a ton of, the only thing it won't determine for you really is disk. It'll say whether it's like low, moderate, or high throughput for network traffic, all that. The only thing you pick just completely independent of instance types is the amount of disk space, really, and whether or not you want SSD or disk or whatever. This is a good example of where people just do incredibly stupid stuff on their card. They'll either forget they spun up an instance and just leave it, and they'll see it on their credit card report. They bill monthly, so you won't find out until a month later. If you're an actually good account owner, you can set it up so you find out more than a month later, but generally those people who do that don't set up their account like that. And if you pick an enormous instance and you meant to pick a small instance, it's a very, very, very costly mistake. Yeah. Windows and Linux, they also have EC2 instances. Today even, we needed a Splunk server. In a place called AWS Marketplace, you just pick out Splunk server, run, and it'll spin up a predefined Splunk server. They have a lot of basically templates. They're called AMIs. It's Amazon Machine Image. So they're basically images. You got to be careful about hidden costs with AMIs. Some are bring your own license. So like with Splunk, you have to buy a license to it unless you're doing really small stuff. Bring your own license means we won't deal with the license at all. You can just go bring your own license. If it's not bring your own license, it might be attaching a license. Additionally, there might be an additional cost for that AMI. People can assign a static cost to their AMI, basically saying tack on an extra $1 an hour for whoever's using my AMI. So be very careful about not picking somebody who's just being a dick and selling an AMI But yeah, AMIs are a lot of fun. You can also make your own AMIs, and you can publish your own AMIs. For instance, at our company, we have AMIs of common server types we spin up on premises. Just heaven forbid we get hit by like a lightning storm in both our data centers or something, we can spin up AMIs of the kind of work we do on premises in AWS and just recover as quickly as possible. EC2, you can also, a lot of people don't necessarily know this. By default, if you're just going in and using EC2, it's on demand. You can bid on instances. So you can say I'm willing to pay up to this amount, and you can make your bill a lot smaller. But it comes with the side effect of if the bid price is lower than, like if you're bidding hourly and ultimately they come back around and it's now more expensive than what you've been bidding, I believe they give you a grace period on your instance, and then after that they shut it down. So you shouldn't be bidding on like super, super, super mission critical services. A couple companies I've talked to have, instead of doing just a couple on-demand instances, they'll bid. They're called spot instances. They'll bid on instances, and they'll put them all behind like some sort of load balancer. So if one goes down because the bid price was too low, they're not ruined. So there's other ways to engineer it to kind of get a middle ground going. But at that point, you might be burning engineering hours that are more expensive than the actual instances. So don't over-engineer it. The EC2 metadata service. There's a lot of articles about how I use the EC2 metadata service to hack this, and then like you get to the bottom of the article and almost never do they do something spectacular with it. But raise your hand if you are familiar with like the 169.254. whatever IP address. Okay, so yeah, so it's called the IP address. The idea of it is if you don't get an IP address on a network, they just assign you, it's like 169.254. something. This isn't it. Like it's just a random one, I'm pretty sure, under 169.254. But it's like that if you literally can't get an IP address from a network, we're just going to give it to you. Symptoms, if it's just your laptop or something, symptoms tend to be that you're just disconnected from the network because nobody knows how to handle an IP address at like the router level or anything. But they basically host an API on the IP address. So what that means is you can query it with, if it was an interactive like Windows server, you could pull up Internet Explorer and do this if you wanted to. In a Linux server, I would use curl. Anything to just make HTTP requests. You can request different data about the instance from within the instance, like the identifier, the image that it was spun up with, the host name, the instance ID. It says public keys. You can query like the name of the key that was used to spin it up, all kinds of stuff like that. In very, very, very extreme cases, if they spun it up with something called a role, which basically gives it access keys to more of your AWS environment, you can pull access keys out of the metadata service. This is usually what people write articles on, is pulling out access keys from that. But you need to spin up your EC2 instance in a certain way to do that. So usually those articles turn out to just be theory. But you would theoretically be able to pull out access keys to say they spun up the EC2 instance with the rights to access their S3 data. You might be able to pull out those keys and then just start querying their S3 data. It's a good way to move laterally through an AWS account if you get into it. IAM, let me see how I'm doing for time. Okay, IAM, Identity and Access Management. Who can log into the console? Who can have programmatic access? That usually means like API access, or 99% of tools will ask you for access keys rather than your AWS logon. That's programmatic access. It'll generate you keys. You have to be really careful about keys, but I'll get into that in 2 seconds. Rarely would a CTF give you console access. It wouldn't give you pretty access like this because it's just a pain to regulate at scale, and it's a pain to regulate like somebody in the CTF not doing something incredibly stupid. If you do something incredibly stupid at your company with a console, they can fire you or audit it. They have a means of actually following up with it. If you do it at a CTF, they're just like, well, shit, the CTF's over. So you won't see a CTF like using console really. So they'll give you programmatic access, or you'll have to take programmatic access. And it's a user experience pain if you really, really heavily restrict like people's permissions, and then you turn around and give them console. Like it'll throw error. Like for instance, they'll try to visit S3, and it'll throw like 50 errors saying you don't have rights to S3, or say they have rights to list buckets, but they don't have rights to like query the metadata about buckets. Or this is a weird example that isn't necessarily applicable, but that kind of discrepancy could throw an error in the console saying, shit broke, yo, you didn't give them enough permissions. So, but if you do everything right, and it's something simple, like I want them to have the right to spin up instances and do whatever they want in EC2, but I don't want them to have the right to go into our DNS service or something like that. It's pretty easy to segregate and just have them do it in console. It's in JSON. You also have roles. It's like user permissions, but for an actual service. So you can tell EC2 from EC2 attached to this instance. I want this instance to be able to access S3 and IAM or whatever. You can let services access other services. IAM makes revocation easy. If Zane works at our company and we give him S3 access and Zane is brutally fired, we can just terminate his IAM account and he'll lose his access. We can also, if we granted him programmatic access, we can just yank his key out and kill his key, and we can kill like his interactive logon, and his account is technically still there, but all of his means of access are killed.
I'm getting fucked over a lot tonight.
Yeah, you're getting ruined. AWS keys and leakage. Very, 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 very common. You get an access key, you get an access ID. That's basically the programmatic equivalent of your username, but you can have multiple. That's on purpose. If you have 3 different programs, for instance, you're going to want them all to have different keys. So then if one just is ripe of abuse, you can rip that key out and disable it without destroying your other 2 applications. It's kind of an example of why you can have multiple keys to one account. In your secret key, the secret key is basically the password to your actual access key, ID, access key, whatever. So those in combination generally grant you the rights of your account. People will leak them. Since they bake into applications, people will do stupid stuff. I'm totally clipping this out of the presentation, but oh, I have a better one. Here we go. You remove AWS credentials. See, Git is a historical record of your code. People don't seem to remember this. So they'll push their keys to GitHub or something, go, oh crap, and push a new commit saying delete them. These 2 are chuckling because I definitely shouldn't be doing this. But, yeah, it's fine. So they'll say, shoot, remove them, but it's a historical record. So you just click and it shows the diff. And there's their keys, even though it's not in their live code base. So people leak AWS credentials like they're candy. It's just incredibly stupid. There are ways to not only avoid this, but holy crap, give me back. I'm totally ripping that out of the presentation, or blurring it. I'll just blur it.
It's not like a secret.
Yeah, it's the fact that they're there is no secret, but I don't want anybody to like pause the YouTube video, turn around and use the keys or something.
I mean, if they didn't indicate their keys afterwards, you know. Like,
I mean, morally it's their fault, but legally I'm not sure. Just deleting your keys from your code might not be enough. You might need to actually do some degree of like rewriting history if you're using Git or something like that. There are scanners. So this is a scanner called Trufflehog. It will scan your whole Git repository for AWS keys or otherwise sensitive data. Not just the live code base, but your history. Because that's where 99% of people leak their keys. It's just in history. Another fun fact about leakage, just random Good Samaritans, and I think also AWS started doing it. Well, they definitely did it. Will email you saying, hey, we noticed your keys are just sitting on the internet. Maybe you should rotate them. I once, I think it was in high school, accidentally pushed my keys to GitHub, and I got an email within 30 seconds from just a random email address being like, LOL, I found your keys. So, good guys and bad guys are looking for them. Yeah. Demonstration. I'll do a brief one. But yeah. And then, but first, does anybody have any questions about AWS? I've done a lot with AWS. My dad he does the Intel side of AWS, basically the CIA contracts and all that. If you've ever heard of C2S, it's that and then a couple other contracts. My company does a ton of forensics operations in AWS, and I manage that. And Nikki, as previously referenced, was an intern at AWS Security 3 times. That's in Herndon, right? Yeah.
2 times in Herndon, 1 time in Seattle.
Yeah, so their home base is in Seattle. So, as is, I think, all of Amazon, right? Yeah. But yeah, does anybody have any questions about AWS? This was a bit of a long spiel, so. Okay. You can either look at flaws.cloud, or I'll poke into AWS a little bit now on my company account. Let the record show I screened it. Like, I went through our EC2 panel and was like, is there anything of value? At Crypsys, we identify cases with something called a CEN, and they're just incremental according to the case we get. So at Crypsys, we don't say we have GMU as a client. We say CEN 18123. So that's the main reason I feel comfortable doing this, is because I went through our AWS records recently, and it's all just CENs, and they're meaningless. So. Let me remote in. Actually, I don't need the VP. Yeah, I talked about it. Oh my god, what's the wrong button? That's a good way of showing it to you. So EC2. We only have 13 running right now, like 10 of which are test instances because we don't use EC2 that much. But you'll see availability zone, that's basically where they are. Whether or not they're running or stopped, there's basically 3 states. I think you can suspend or something technically, but running, stop as in it's off, but you can turn it back on. Terminated, just you killed it and it's going away now, and it'll disappear from the panel like a minute later. Public IP addresses, keys you're using, how big the instance is. So T2 micro, super small, enormous, super small. You'll notice for cost purposes, most of the enormous ones right now are off. Given I'm a measly hourly college employee, it's a really easy way for me to cost justify stuff by running down enormous EC2 instances and turning them off. So it's kind of one of the million ways of cost justify at work. I haven't screened much more than this, so I'm not going to go much past this, but you have your services drop down. That's where all your services are. They categorize them a little bit. We have a search head in Splunk where you log into Splunk, you can search and say, what has Sean Green been up to in the past week? It'll list the API calls for his account in the past week, et cetera, et cetera. So that's generally how R and a lot of same AWS accounts look. So, fun fact, Mason CC, both of these, or this, uses AWS. So this, our join, our Slack uses AWS, and the weekly announcement bot uses AWS. It uses a function called Lambda, which just runs arbitrary Python code. It's very cheap because you only pay for the runtime. Generally not for long tasks and not for computationally expensive tasks usually. And it finds something called API Gateway to just kind of give it, for lack of a better explanation, a URL. And you'll notice give it a username. See it sends it to a AWS URL. That's an AWS. You can see it's like blah blah blah, execute API dot the region it's in, which is AP South. I think it's Asia Pacific. I don't know why I put it there. It's fine. Slack invites, and then it just sends that data to a function that runs. And it's like less than a cent per run or something ridiculous. And then it sends an invite. The meeting bot is just a Lambda function that runs weekly. So we run this thing on packets. So yeah. If you don't have any further questions, then you can go to flaws.cloud and get yourself an education account, whether that's the regular or the starter. It takes like 48 hours to process, or just